Welcome back, engineering design students. Today we are going to learn about programming the Arduino and building simple circuits using it. So let's dive in. First thing we're going to do is we're going to click on Learn. Let's learn some stuff. And then we're going to click on Projects. And then we're going to click on Circuits. So go to Circuits, Projects, inside Learn, and show all the Arduino options. And once it opens, you scroll past all these single classes to these grouped lessons. Again, when we click on Introduction, it takes us to the very bottom. So we scroll up to the top. Hopefully 1 through 3 you have already done, so it says like completed over here or something. And now we're going to go to 5, build a simple circuit. Again, we're skipping number 4 because that requires you to have a physical Arduino and shows you how to work with a physical Arduino. We are just using a simulator. So let's click on 5, and when that opens up, it tells you that we are going to be making an LED flash. No way! That's amazing! I know, I'm excited too. This first page just says, hey, we're going to build something. Click on next, and now it says it's going to make an LED blank. That's what we're going to do. Woohoo! And here's what it ultimately is going to look like. This is the circuit we're going to build, but we have to build it ourselves, as they give us nothing but the Arduino and the breadboard. So please do not go ahead. I strongly recommend that you listen because I'm going to show you a couple things that they don't show you here. First thing I want to show you is it says connect to power. So we're going to be connecting the power, and the power we're going to be using is 5 volts. So if I look at the Arduino and I zoom in, let's pull that up a little bit more. I see down here at the bottom there's a bunch of pins. One of them is the 5 volt pin and the other is the 3.3 volt pin. So today we're going to be using the 5 volt pin. That means that the power coming out is 5 volts. So to connect, there we go, computer. To connect the 5 volt pin to the breadboard, what we want to do is we want to connect that 5 volt to, remember, on the breadboard, there's the positive, and that's where the electrons go in, and the negative, that's where the electrons come out. And we're going to start by sending them in, and we're going to send specifically 5 volts of them. So let's click on the 5 volt. And now technically you could go anywhere along this bottom line. All of these are possible pins, but it's customary that you would go all the way to the left. That's just how people do it. Click on 2, and that'll make it red, and the red wire says that this is where the electrons enter. That's what red means. So we have now powered the breadboard. Let's go next. Next is ground. So electrons have a way in, but they have no way out of the breadboard. So let's look at that. There's actually a couple different spots where ground is. Now, the most obvious spot is right next to 5 volt down at the bottom. There's 2 grounds there, and these are both ways where the electricity can come back in and then leave. So we can use either of those, and it's very customary that if you're using the 5 volt or the 3.3 that you would use this one right next door. That's very normal. But I think it's worth pointing out that there's also a ground up here, and it's interchangeable. As in, I could have my ground either come from this ground up here at the top or this ground down at the bottom. They both lead to the ground. They both are exits for the electricity. So I'm going to do the customary thing. I'm going to go right next to the 5 volt. I'm going to click on the ground. Again, I could do any pin here, but I'm going to go all the way to the left. And I'm going to click on number 1 on my keyboard. That'll change it to black. And black wire means, hey, this is the way out. You found a way out? I did, and it connects to the ground. Woohoo! So let's keep going. Now it says connect an LED and a resistor. And it says that the LED has to be connected to pin 13. So at the bottom of this are the analog pins, and at the top of this are the digital pins. So let's go take a quick look at those. So the digital pins, here they are. They go from 0 to 13. And we're going to be using 13. Does it have to be 13? No, we could do from 0 to 13. Doesn't matter. But this particular project says, hey, do me a favor, use pin 13. Okay, I'm good, sheeple. I'll do just as you say. And I will connect 13. Oh, why don't we go to 13? That seems nice. I click on 2. And the reason I click on 2 is what this Arduino is going to do. We're going to ultimately program this chip right here. We're going to write code so that this chip chooses where the power goes. And in this one, we're going to say, send the power to 13. So what's really going to happen when this is all done is the power is not going to go in through this wire. In fact, I can even delete that wire. You shouldn't. I will. It's best to just stick with always powering up a breadboard and leaving that positive and negative terminal, leave those connected. But I just want to prove a point, so I'm going to leave this. What the chip on this Arduino is going to do is it's going to say when to power up pin 13, when to send power out pin 13. And that will affect an LED. So I drop an LED in. Again, the power at some point is going to come out 13. It'll go underneath here. It'll go in the anode, out the cathode, and now it needs to return home. It needs to return to any pin here. But this says that not only do we need an LED, we also need a resistor. So I'm going to drop a resistor in as the way out. So now power will come out pin 13, into the anode, out the cathode, through this resistor to the exit. And if you're using LEDs with 5-volt power, it's the resistance that you usually do is 220 ohms. So if you could change your resistor to 220 ohms, 220 ohms, it's just a good habit to get into. So if this were a physical breadboard, you'd just reach for your 220 ohm resistor. How do you know what the resistance is of a resistor? And the answer is these colors. If you look, we have brown, red, red, and that tells people that it's a 220 ohm resistor. And if I change this, the brown becomes yellow. And that says that that's a 220 kilo ohm resistor. But we just want 220 regular ohms, so that becomes brown again. I probably won't teach you how to read that. It's a super easy thing to learn on your own, but maybe in the future I will. Okay, so now we have it all set up. Looks a lot like this picture, except I removed the power to the plus. And we hit next. And now it says, let's see if it works. Okay, click on Start Simulation. And I'm going to zoom in a little, and you're going to be amazed that the LED turns on and off, proving that the power has to be coming out of pin 13 because that's the only place the power goes in. So somehow this chip is sending power to pin 13, it's sending it now, and then it's turning it off, and then turning it on, and turning it off, and turning it on, and turning it off, and turning it on, and turning it off. And that's what this chip is doing. How does this chip know how to do that? Well, let's click next and find out. And it says, oh, the code editor. Oh, there's code running. There's like programmable code. Well, where's the code? The answer is here, right here. Click on this button right here, code. And what pops out is this pre-made code. So the first thing I notice is I see LED equals 13. So the word, the variable LED equals 13. So, oh, hey, that 13. So what we're saying is, hey, just deal with pin 13. Okay, and it has this stuff and whatever. And I see down here, I see, oh, wait, digital write LED. And LED means 13. So digitally turn pin 13 to high. Turn it on. And then delay 1,000 milliseconds. Delay takes in milliseconds, this function right here. And then turn to low, which means turn it off. And wait. And this is a loop, so it just goes around and around, says turn it on, wait 1,000 milliseconds or 1 second, turn it off, wait 1,000 milliseconds or 1 second. On 1 second, off 1 second, on 1 second. And if I hit start, that's exactly what happens. Woohoo! Isn't that amazing? Now, let's go next. Hey, it says you can muck with it now. Okay, how do you want me to muck with it? Well, that's a really good question. How about if we, I don't know, change the delay? Yay! So let's change the delay from 1,000 to 100. So that's 0.1 seconds. So it's going to turn it on, wait 0.1 seconds, turn it off, wait a second. And when I hit start simulation, you'll notice it doesn't stay on very long. It stays on much shorter amount of time. Yeah, there it is. Stop simulation. So every time I edit this code, when I hit start simulation, what this does is it sends this code to this chip. And then the chip will do whatever this code says, assuming that you've done it correctly, right? And worth pointing out, what happens if I remove this semicolon and I hit start simulation? It says, "Mah." It's pretty overt about this. And the nice thing is it says, it seems like your code has some errors. Yep, in function void loop, it says line 15, that's what this 15 is. It's expecting a semicolon before digital write. So it's expecting a semicolon sometime before this line. What if I put it right there? And I hit start simulation, and then it puts the nice code in and all that stuff. And now it goes on for a second, off for a second, on for a second, off for a second, and works perfectly. And to get rid of this screen, you just click on code again, and that'll disappear. So it toggles on and off, open and close. Right, let's click next. Let's see what else we got. Hey, we got nothing. Woohoo! Isn't that amazing? Now, your homework is going to be, instead of this LED, I would like you to use an RGB LED. There it is. So if you type in RGB, it's right there. And an RGB, couple quick things. This pin, if this pin gets power, this is a green anode, it lights up green. If this pin gets powered, it lights up blue. This is the cathode. This is the exit. So this needs to be attached to the exit somehow. And if this pin gets powered, it lights up red. So this particular LED can do green, blue, and red. And if blue and red both get power, then it lights up purple, because blue plus red is purple. So your homework is swap this out with this, and I'd like you to be able to, well, yeah, just do that. That's fine. You can choose any color. You can choose whether you want it to be green, blue, or red. That's your homework. Swap this out for that and light up the green, light up the blue, light up the red. In a perfect world, you'd try one at a time, right, and get all three to work. So that's all I got for you. Good luck.